In this presentation, we will explore the crucial role of field density testing in construction and geotechnical engineering. We will delve into the different methods, applications, and importance of measuring soil density accurately. By understanding these concepts, you can ensure the strength, stability, and performance of various structures and projects. Field density testing plays a vital role in ensuring the quality and safety of various construction projects. It involves measuring the actual density of soil in its undisturbed state at a particular location. This value is then compared to the desired compaction level specified for the project, which is crucial for factors like bearing capacity, settlement, and drainage. Accurate field density testing offers several significant benefits. It guarantees that the soil is adequately compacted, enhancing its strength and ability to support structures without settling or collapsing. This prevents costly failures and ensures the longevity and safety of construction projects. Additionally, optimal compaction minimizes material usage and reduces construction costs. Finally, field density testing adheres to regulatory requirements and project specifications, ensuring compliance and quality assurance. Several methods are available for field density testing, each with its advantages and limitations. The sand cone method is a simple and cost-effective option, suitable for cohesive soils. The nuclear gauge method offers rapid and accurate measurements but requires specific safety precautions due to radioactive sources. The water balloon method is a non-destructive approach, ideal for sensitive environments, but may be less accurate than other methods. Field density testing follows a standardized procedure to ensure consistency and accuracy. The process involves preparing the test area, selecting and calibrating the equipment, conducting the test using the chosen method following its specific steps, recording and calculating the results, comparing the obtained density to the desired level, and repeating the test at various locations to evaluate uniformity. Field density testing finds application in various construction and geotechnical fields. It is crucial for ensuring the proper compaction of soil in road and pavement construction, guarantees stability and prevents rutting or cracking, foundation preparation, ensures adequate load-bearing capacity for structures, embankment and dam construction, maintains structural integrity and prevents failure, landfill construction, optimizes space utilization and ensures environmental compliance, agricultural field management, improves soil aeration, drainage, and crop yield. Field density testing is a critical tool for ensuring the quality and safety of construction projects. Accurate measurements lead to stronger, more durable, and cost-effective structures. Choosing the appropriate method and following proper procedures are essential for reliable,